Solving quadratic equation, completing the square. In previous video, we have learned how to solve a quadratic equations by using factorizations method. And in this video, we are going to discuss another method called the completing square to solve a quadratic equations. Let's see this example. This is a quadratic equations. Now, I'm going to show you that if a quadratic equation is written in this form, then we can solve it easily. Previously, we have learned that if x squared equal to a, we can eliminate the square easily by applying square roots on both sides. Okay, so after applying the square roots on both sides, then the square here is eliminated, and therefore it becomes x. And on the right hand side, we have positive, negative square root of a. So we are going to use this in these equations. So therefore, if we have x plus 6 squared equal to 9, then we eliminate the square here by applying the square root. Then we have this x plus 6 here, and then we have positive, negative square root of 9. After that, we shift this positive 6 to the right hand side, and the square root of 9 is 3. Yeah? So we have x equal to negative 6 positive plus minus 3, and therefore negative 6 minus 3 we have negative 9, or negative 6 plus 3 we have negative 3, and these are the solutions for these quadratic equations. Okay. Again, if we can write a quadratic equations in this form, then we can solve it easily. Okay. So now the problem is how to write a quadratic equation from this general form to a form like this, and the process of doing so is called the completing the square. Okay, and this is what we're going to discuss in this video. Now let's say we have a quadratic equation, x squared plus 12x minus 45 equals 0. Now this is a general form of quadratic equations, right? And we would like to rewrite these equations into this form, and let's call this the square form of quadratic equations. And to do this, first of all, we need to know the structure of this square, and the best way to do this is to visualize it by using a big square. Let's say we have a big square, and the dimensions of this square is x plus 6 and x plus 6. And therefore, the area of this square is x plus 6 square, right? X plus 6 times x plus 6. Okay, which is equal to x plus 6 square, and this is the area of this big square. Try to remember this. The area of this big square is x plus 6 square, and let's divide this big square into 4 sections. Okay, and we have another square here, and let's say the dimensions of this square is x times x. If the dimensions of this square is x, then what is the length of this point to this point? What do you think? From this point to this point is x, and from this point to this point is x plus 6, and therefore the length of this part must be 6, right? Okay, x and 6, and therefore the length is x plus 6, and so does the width for this part, which is also 6. Okay. Now, if the dimensions of this square is x, and therefore the area of this square must be x square, right? Okay. And how about the areas of this rectangle here? Yeah, the length is 6 and the width is x, and therefore the area is 6x, and so does this one. The length is x, the width is 6, and therefore the area is 6x. And this one, the length is 6 and the width is also 6, and therefore the area of this small square here is 6 square. We can break down the square of these expressions into 4 components, which is x squared, 6x, 6x, and 6 square. Now try to remember this, because this is very important for us to rewrite this quadratic equation from general form to the square form. Now let's go back to the equations here, the general form, okay? To see whether we can rewrite the equations into the square forms like this. Now, the very first things that we are going to do is to shift this negative 45 to the right hand side. We can see that the right hand side we have a constant here. we would like to see whether we can form the square of the expressions by just using this x squared and x terms or not. Okay, so by shifting this negative 45 to the right, become positive 45, and then this is what we get. Okay, now to help us to understand better how to construct the square of these expressions, let's use the big squares to help us. Okay, so we have this big square here, and then so let's try to see we have all these 4 components to form the square or not. Okay, let's insert the x square first. Okay, so this is the x square. Now we know that these 2 are the x terms. Okay, so we divide this 12x equally, and 12 divided by 12 divided by 2, we get 6x. Okay, so we put these 2 6x terms into these 2 rectangle. Now we can see that the square is still incomplete. This is an incomplete square, and to make this square complete, we need to fill in something here. Okay, so to find out what we need to fill in here, we need to know the dimensions of this big square. Okay, the areas of this square here is x squared, and therefore the dimensions must be x times x. Okay, and if this is 6x, then the edge here must be 6, right? So that's 6 times x, 6x. And this one is 6x, and this is x, and therefore this must be 6 as well, right? Okay, then only we can get 6x and 6x here. Okay, now we know that the length of this square is 6, and the width is also 6, and therefore the areas of these components must be 6 square, because 6 times 6 is equal to 6 square. And now we know that the missing part is 6 square. Okay, therefore to make this square complete, we need to add a 6 square to these 2 terms. Okay, to complete the square, to make the square complete, we need to add a 6 square terms into these 2 terms. Okay, let's try to do this. Okay, now this and this still the same. I just shift this 45 to the right so that I have a space for my 6 square, and let's add this 6 square into the equations. Now to make this equation balance, I also need to add a positive 6 square to the right hand side, right? Okay, I can't just simply add a 6 square here. To make the equation balance, I need to add 6 square to both sides. Okay, so I add another 6 square on the right hand side. Now after adding this 6 square into these 2 terms, then the square become complete, and that's why this is called completing the square. Okay, so we add a missing part into the square to make the square complete. This is completing square. Okay, so once we got this, then straight away we can tell that these expressions can be written as x plus 6 square, right? Because here is x plus 6, here is x plus 6, and therefore the area of this big rectangle is x plus 6 square. So this x squared plus 12x plus 6 square is equal to brackets x plus 6 square. Okay, on the right hand side we have 45, and 6 square equal to 36. So 45 plus 36, we got 81. Okay, so this is how we complete the square, okay, of quadratic equations. After we write the quadratic equations in the square form, then we can solve it easily, right? If you still remember. So x plus 6 squared equals to 81. To eliminate the square, then we use the square root. Okay, so after eliminating the square, then the right hand side will become a positive negative square root of 81, and we shift this negative positive 6 to the right hand side, then we get negative 6, and square root of 81 is 9. Negative 6 minus 9, we got negative 15, and negative 6 plus 9, we got 3, and this is the answer. Okay, the solution for this equation is x equal to negative 15 or x equal to 3, and this is how we solve for quadratic equations by using the completing the square method. So this is the question: solve the following quadratic equations by using completing the square. And let's start with the first question. Question A. let's rewrite the questions. So we have x squared plus 4x minus 11 equal to 0. Okay, and we learned that to complete the square, we need to have the 4 components of the square, right? The first one is the x squared. So we have x squared. And the second one is to split this 4x into 2. 4 divided by 2, we got 2x. Okay, so plus 2x plus 2x. And then this negative 11 need to be shifted to the right hand side, so it becomes positive 11. And to make the square complete, we need to plus the square of the coefficients of the x. So we need to plus 2 square. And to make the equation balance, we need to plus the 2 squares on the right hand side as well. And now the square has been completed, and straight away we can write this as x plus 2 square and equal to 11 plus 4, right? And to eliminate the square here, we apply the square roots on both sides, so this becomes x plus 2 equal to positive negative the square root of 15, and therefore my x is equal to negative 2 positive negative 15, and this is a solution. Okay, now let's see question B. Question B is a little bit different from question A because the coefficients of the x term is negative. Okay, now before we start, let's have a look at this the difference between x plus a square and x minus a square. What's the difference between these two? Okay, to expand this, we rewrite the equations as x plus a multiplied by x plus a. Okay, so this is x plus a square, and to expand it, we get x squared plus ax plus ax plus a square. For x minus a square, we do the same things. We rewrite it. So x minus a, and this become x squared minus ax plus a square. Okay, now we can see that the only difference is the x term here, right? This is plus ax, and this is minus ax. And if this is minus ax, then the square of the expression is x minus a. And if this is plus ax, then the expression is plus a is x plus a, right? Okay, so let's move on to B here. B, and let's rewrite the equations. X squared minus 4x plus 3 equal to 0. And to complete the square, we need to have the 4 components, right? So the first one is the x squared, yes, we already have that. And the second one is to split this negative 4x equally into 2 parts, so it becomes minus 2x minus 2x. Okay, and then we shift this positive 3 to the right hand side, it becomes negative 3. Yeah? Okay, now to complete the square, we need to add a square of the coefficients of the x here, right? So we plus negative 2 square. Okay, and to make the equation balance, we need to add the negative 2 square to the right hand side as well. Now the square become complete, and straight away we can write this as x minus 2 square, right? Okay, and this is negative 3 plus 4. Okay, to eliminate the square, we apply square roots on both sides. So x minus 2 equal to positive negative square root of 1. Negative 3 plus 4 equal to 1. And therefore, x equal to 2 plus minus, the square root of 1 is 1. So let's put it 1. And therefore, x is equal to 2 minus 1. We have 1. Or x is equal to 2 plus 1, 3. And this is the answer. Okay, so take note that if the coefficients of x is negative, we still do the same thing. Okay, yeah, almost the same. The process is almost the same, but the expressions become x minus 2, not x plus 2. Okay. Now let's see question C. For question C, the coefficients of x is an odd number. For A and B, these are even numbers, right? But for C, this is odd numbers, and the process is more or less the same. Okay, so let's copy the question C. So we have x squared plus 7x equal to 15. Okay, so to complete the square, we need to have the 4 components. The first one is the x squared. And the second one is to split this 7x equally into 2. And 7 divided by 2, we have 7 over 2x. 7 over 2x plus 7 over 2x. And then we need to add the square of the coefficients of x here to the left-hand side. So it becomes 7 over 2 square. Okay. And so we have a 15 here, and then to make the equation balance, we need to add 7 over 2 squared to the right hand side. So it becomes 7 over 2 squared. Okay. So we have all the 4 components. Now the square is complete, so we can straight away write the square x plus 7 over 2 square. Okay, equal to 15 plus the square of 7 is 49, and the square of 2 is 4. And to eliminate the square, we apply square root. So, okay, so this becomes positive, negative. Okay, square root. So this is the fractions. To solve the problems with additions of fractions, we need to make them to have same denominators. Okay, to make them to have same denominators, so the 15s we multiplied it by 4, it becomes 60. 60 plus 49 divided by 4. Okay, so then my x is equal to, shift this to the right, it becomes negative 7 over 2, and then plus minus, this become 109 over 4. Okay, so so this is solutions. Okay, so if it's odd numbers, for the coefficients of x, when we split this into 2, we write the answer in the fraction form, 7 over 2, 7 over 2. Okay. Now for question D, the coefficients of x is a fractions. Okay, it's a fraction. So let's see. D, let's copy the questions. So we have x squared plus 3 over 4 x minus 4 equal to 0. Okay, so we need to have the 4 components of the complete square. So the first one is x squared. The second one is we split this 4 over 3x equally into 2. Okay, so let's write it here. It's 3 over 4x divided by 2. So this is equal to 3 over 4x times 1 over 2. Okay, and then is 3 multiplied by 1, we still have 3. And then 4 multiplied by 2, we have 8. And it becomes 3 over 8x. Okay, 3 over 8x. So we split this 4 over 3x equally into 2. It becomes 3 over 8x plus 3 over 8x. Okay, and we shift this negative 4 to the right. It becomes 4. And then to complete the square, we need to add the square of this into the equation. So it becomes 3 over 8 square, and 3 over 8 square to the right to make it balance. And now the square is completed, and therefore we can straight away write the equation. This is x plus 3/8 square, okay, equal to 4 plus 9/64. Therefore my x plus 3/8 is equal to positive negative. Now to solve the equations that involve fractions, we need to have the same denominators for both numbers, okay? So therefore this become 252 plus 9/64, okay? And therefore my x is equal to, I shift this positive 3/8 to the right, it becomes negative 3/8, and then positive negative square root 261/64, and this is the answer. Let me erase this so that we can see it easily. Okay, so this is how we solve the questions that have fractions as the coefficients of x. Now let's see the last questions, 3x squared plus 6x minus 7. Now this question is a little bit complicated because the coefficients of x squared is not equal to 1. For a to d, the coefficients of the x squared is equal to 1, but this one is not equal to 1. So we need to get rid of this 3 first before we complete the square. Now let's see what can we do with this. Okay, let's copy the questions. Okay, this is E, and we have 3x squared plus 6x minus 7 equal to 0. Now to get rid of this 3, we can multiply these equations by 1/3, or we divide each terms by 3. Okay, so what we do is this one we divided by 3, this one we divided by 3, and this one we divided by 3. Okay, so then the equations will become x squared plus 6 divided by 3, we have 2, so 2x, and then it's minus 7/3 equal to 0. Now the coefficients of x squared become 1, and then we can complete the square easily now. Okay, so first of all, we need to find the 4 components of the complete square. So we have x squared, and we split this into 2, so plus x plus x. And then we shift this negative 7/3 to the right, it becomes 7/3. And to make the square complete, we need to plus the square of the coefficients of x here, it become is 1 square. Okay, and to make the equations balance, we need to have 1 square at the right, and the square is complete. So therefore this is x plus 1 square equal to 7/3 plus, now this becomes 3/3. To solve the fractions, we need to have the same denominators. To eliminate the square, we apply square root, so it becomes positive negative square root. Okay, 7 plus 3 become 10, and this is 3. Okay, so therefore my x equal to -1 plus minus 10/3. Okay, so this is how we solve the questions where the coefficients of x squared is not equal to 1. Okay, we multiply the equations by 1/3, because this is 3, so we multiply by 1/3. If this is 4, then we multiply it by 1/4 and so on. And then we can change the coefficients to 1 for the terms x squared.